Hope you all are good and doing well for the preparation of your CAIs. Guys, today we are talking about the kinematics again. When the acceleration is constant. Uh, Question states a remote control car travels forward for 6 meter per second in drive and backward for 3 meter per second in reverse. The car travels for 10 seconds in drive before traveling for 5 seconds in reverse. So here are two conditions. One is when it is driving forward and when it is driving reverse. So we will deal with them accordingly. First of all, when it's driving forward, forward drive, and here we can write reverse drive. For forward drive, it's travel forward at speed of 6 meter per second. So v is given to be 6 meter per second, and backward it is v is what, 3 meter per second. The car travels a distance for 10 seconds in drive before, so it means t for forward drive before traveling for 5 in reverse. Okay, that is 10 seconds, and here t is taken for 5 seconds in reverse. Find a displacement from its straight point. Okay, because cars goes drive and reverse and then drives and reverse, the process is continued. We have to find out how long distance it travels for the set data. So here, if we say for forward drive, S is equal to v times t, the simple relations, that is 6 times 10, it means 60 meter it will travel for the forward drive with a speed of 6 meter per second for 10 seconds. And similarly, for distance travel for the reverse, same v cross t. So reverse will be v is here 3 and time is 5, so we can say 15 seconds. So the question is find the displacement from its starting point. So as we know, displacement is a vector quantity. Because displacement is a vector quantity, so we can say uh, forward direction is taken as positive and reverse direction is taken as negative. So displacement covered will be from forward minus reverse. So forward is 60 versus 15, so it goes to be 45 meter, that is. So here don't forget to keep this point in mind, that you are talking about the what quantity? Vector quantity. So its direction matter for it. So as the car moves forward, if we take it positive, then in reverse order it's will cover a displacement with a negative result, right? Okay guys, for the part B, find the average velocity uh, in the direction in which the it is started driving forward. We are talking about forward, so only forward case will be taken place. B I'm doing here, we're looking for average velocity VAV, that is distance for forward divided by total time. So distance in forward direction was 60 and total time was, that was going to be here 10. So what comes 10 or what? Total time was 10 plus 5 15, so we can say 15. So here it goes to be distance traveled by the body is, in the question, it is average velocity in the direction in which the started driving forward. So instead of 60 was the initial when it driving forward backward, So total distance was 45. Here I can say ft, st, total distance divided by total time for the forward. That was 45 divided by 15 will be 3 meter per second will be the average velocity when the car is driving start from in forward direction. And finally the C part of the same question state, find its average speed. So mm, uh, average velocity and average speed. Average speed will be now instead of distance displacement we will write total distance divided by total time. Total, sorry, average here VAV. This I labeled with for average speed because speed is a scalar quantity, so it needs to cover total distance divided by total time. Guys, you need to be very careful for this question, the two B and C, because in first he asks about the average velocity. So average velocity, total displacement divided by total time. This term, this ST represent total displacement because it's a vector quantity, so divided by total time. But average speed, this is average speed. So average speed will be total distance divided by total time. Because once we cover this displacement, so we take reverse as a minus, but total distance mean you once you go one direction plus other reverse direction, the direction doesn't affect, just you need to plus total. So here I will say it will be what total distance will be 60 plus 15, the forward and reverse distance. The total time was 15, so 75 by 15 will give us yeah, it will give 5 meter per second. I hope it is clear. So let me write space for here is 45 meter, right? So this is the final answer for the question number 7. I hope you got it. Okay guys, in question here, question it's written that the speed of sound in wood is 3300 meter per second and the speed of sound in air is this. So we can start writing first two cases in speed in air and speed in woods. Two different things we have. So speed in air, that is v is given to be 330 meter per second, and in woods it will be it is given that 3300 meter per second. A hammer hits one end of a 33-meter long plank of wood, right? Suppose it's a plank of wood that is going to be hit by the hammer, and that is how much? 33 meters. So S is what? 33 meter. Find the difference in times between the sound waves being detected at the other end of the plank and the sound being detected through the air. Okay. So here we know that S is equal to, I can write here, S is equal to Vt. So for air, S is equal to V times T. So time we are looking for, so T is equal to S over V. S is same for both cases, so T for air is we can say 33 by 330. So it comes to be 0.1 second when it's time of sound in air, and on the other hand here it will be I can say T is equal to S over V. S again it's remain 33, and V here for wood is this one, it's given. So on calculator we can get it will be 0.01 second. So as we are looking for the difference in times, So difference will be time. 0.1 minus 0.01. Time can never be negative. So largest value minus minimum value will give us the result, that is 0.09 second. I hope it is clear. This is a simple question to be asked. Okay, guys, here's another question. Two cars are racing over the same distance. The distance is same. They start at the same time, but one finish 8 seconds before the other. The faster one average speed is 45 meter per second, and the slower one is with the 44 meter per second. Find the length of the race. Okay, from here A and B, they are having a race like this. They need to point reach this point. The distance is same as, and at the start time, and start time is fine for same. We are looking for this distance with speed. Here it is, A is 45 meter per second and B is 44 meter per second. So again here case study of two things. The faster and slower, right? Two cars, one is faster and is slower, and they cover the distance that is the same, say, as for both cases. Both have to cover this distance to win the race. So for the faster, if you go with S is equal to Vt, so S we don't know here, but what is the V? V for faster, suppose that is 45. Yeah, it is given 45, and time we don't know the time. Two things here. Suppose this is equation number one for the faster one. Now take the other case, the slower one. It's given that one finish 8 seconds before the other. It means the time taken by the slower is 8 seconds more because it's slower. So here again S is equal to Vt, but for the slower T is equal to T plus 8 because it is slower, so it takes 5 seconds more. So S will be, and speed of slower is given to be 44 and T plus 8. So S will be S slower and F for faster. We can symbolize this as well. So it will 44 T plus 8 times 44, 8 for the 32, or 352, right? So here as S faster and S slower are both equal because they have to cover the same distance. So we can equate them. 45t is equal to 44t plus 352. So I can say the time once you take this other side. 45 minus 44t is 352 second. There is time taken by the both cars to cover that distance. So, but we are interested to find the length of the race. So S will be what? From any one equation. From the first, we can say from first S equal to 45 times 352 will give us the final answer. That will be calculated as 150,800 meter. This is the answer of this question. I hope it is clear. Oh guys, here another question, important look to be. The two air hockey pucks are 2 meter apart. One is struck and moves directly towards the other at 1.3 meter per second, right? The other is struck 0.2 second later and moves directly towards the first at 1.7 meter per second. Find how far the first buck and has moved, how far the first buck has moved when the collision occurs and how long it has been moving for. Okay, we have to find it s, and we have to find how long mean time. Okay, let's here we have the the puck like a disc on ice skating or ice hockey. When you play on ice skating floor, the hockey, so these are two pucks, and how much distance apart these are is given. They are 2 meter apart, as is they are 2 meter apart. The other puck, and we need to stuck, this will be stuck in this direction and this will be stuck in this direction, and definitely they will come at certain point here, and when the collision occurs, the bang will occur for them, these two, and they will move in different directions, right? Because there are two pucks, so they're colliding here. Okay, this is a simple phenomena. First box, let's take time t, because other stock is 0.2 second later. If it is take time t, then it will be t minus 0.2 other path, right? Because it takes 0.2 second later and move directly towards the first, right? The speeds are given to us. Suppose the first one is speed is given 1.3 meter per second, and the second speed is what, 1.7 meter per second. This was given to us. So this case is simple. S is 2, so we can say as we know, S is equal to Vt. S is equal to Vt for both. S is equal to Vt, and we have to apply this here to get the total distance. So total S will be Vt, you can say V1t, V2t, right? V1t, in here you can say T2, here you can say T1, V1 T1, V1 V2 T2, so plus V2 T2. And now we are going to substitute the values here. It is given to be 2. Let me change the color. Okay, it is 2. V1 is what, 1.3, and time we know is t. V2 is 1.7, and the time here, that is t minus 0.2 second later. Okay, fine. Now do the simple algebraic calculations here. 2 is equal to 1.3t plus 1.7t minus 8 comes to 0.34. So bring everything here, we get 1.7 and this 2 and 3. 3t comes to be 2.34. So t will be, after dividing it, 0.78 second. This is time taken for the clear. It has moving forward, and then only what left, how far distance. So we know S is equal to Vt, first park, distance for the first park. So S equal to what, v was, first park was 1.3, and time taken was 0.78, move forward onward. So S will be 1.01 meter. This will be the final answer for this question. I hope it is clear as well. Let's go with the next. Okay guys, here another question. A sprinter covers 60 meter in 10 seconds, accelerating from a jog. Her final velocity is, we are given S is equal to 60 meter, time taken is 10 seconds, and the final velocity is given, not the initial, final velocity is 9 meters per second, and we have to find what is given. Calculate the acceleration. A we have to cover. A sprinter covers this meter in accelerating from a jog. Okay, as it is not clear here in the question what will be u, we have to find first this one. So we can apply the rule. S is equal to what, acceleration from this one and A as well. In the first case, first find u. S is equal to ut plus half, yani we can say, okay, we can ut plus half at square, but here we don't have this and we don't have this. So, and this whole, we know this whole can be expressed as 1 by 2 times u plus v times t. If you substitute the value of v, you can check it. Then here, if we take v is equal to the first way u plus at, as we have the proof of this one. So yeah, we can trace it back. This is right one. Okay, these are equal. So here I'm going to apply this one. S is equal to half u plus vt. So S is given to be 60. Half u we are looking for, v is 9 and t is 10. So 60 is equal to 2, 5 are 10. So 5u plus 45. So 5u will be 15. So u will be 3. Here seem to be 3 meter per second. So this is u, and now it's easy for us to solve one, that is a is equal to what? V minus u by t. The first equation we can apply. V is 9, u is 3, and t is what? 10. So 0.6 meter per second square is the first answer. And second one is what assumption have been made to answer the question. Now we have to think about this part B. For the assumption, we can say that's made the answer. We can say there are a lot of assumptions. The simple one, we can say uh, the sprinter, you need to point one thing, can keep, because it's a case study for the constant acceleration. So I can say keep a constant acceleration, or you can make other assumptions up to your own mind and up to your own arguments, right? Let's proceed to the next question. Okay guys, this is question. Here it goes. A wagon is accelerating down a hill. You can draw this as well. This is down a hill, not as such. Oops, yeah, a wagon is okay, you can say a car or wagon, whatever. This is going down a hill. By road, yeah. It's going down a hill at constant acceleration is constant here. It took it 1 second more to accelerate from a velocity of, it means velocity of 1 meter per second. It means u is 1 meter per second to a velocity of 5 meter per second. So it takes 1 second more for this case. So and then it took accelerate from a rest to its velocity. Then u becomes it's taken as a 0. No, it's not u. V becomes final becomes 0 to u becomes 1 minus 1 meter per second. Find the acceleration. We are looking for this. Here again, two cases, two part of the question. First part we can say, okay, write it, part 1 of the question and part 2 of the same question. We will deal these two. Two scenario. First one, when it's moving with this, so we can say, we know that a is equal to what? A is equal to v minus u by t, right? We know this formula from the Newton first equation of motion. So here first part, a v is 5. No, it took to accelerate from rest to a velocity of this one. Okay. And time, we don't have time, right? T is not clear for both cases. So 5 minus 1 over t plus 1, because it takes 1 second more to the accelerate for here. Then it took 1 second more when then to accelerate from this to this, right? So here time will be t plus 1, here time will be t. So you can say part 1 and part 2. So we get A is equal to 4 over t plus 1, a relation between A and T. Suppose this is between 1. Let's go with part 2. A is equal to V has become here, it's V is 1, initial is 0, right? Here, sorry, here's initial 0, 1 is V. So 1 minus 0 by t, t will remain t. So we can say A is equal to 1 over t. As we are looking for acceleration, so I better can change the, okay, simplified, equate these two. We are looking for time, so instead of wasting more time on it, I can take t is equal to 1 over a, right? Okay, here t, here it will be further simplified. We can write a t plus a equal to 4. So substituting t is 1 over a plus a equal to 4, so it will be cancelled. 1 plus a equal to 4, so a will be 3 meters per second square. That is the final answer of this question. I hope it is clear. It was so simple question. Take another question. A driver sees a turning 100 meter ahead, right? A driver is going, is a turning like this 100 meter after there is a turning. Okay, she let her car slow and constant deceleration. In here a will be minus 0.4 meter per second because decelerating or retarding. So s is equal to what, 100 meter. Okay, and arrives at a turning 10 second later. So starting t, and then if you 10 t plus 10, it will be 10 second later. Again case. Okay, find the velocity she is traveling at when she reached the turning point. So here we have to find this, and this is starting from with u and at t. Okay, let's start solving this. Okay, we can apply here. Again, the formula S is equal to half u plus v times t, because both are unknown, u and v. So both are unknown. S is 100, 1 by 2 u plus v, and time. Yes, here the time is not given to us. Time is given to be arrive and in 10 second later. Okay, time 10. So you can take it 10. So it becomes simply 10 to the 20 is equal to u plus v. This comes to be equation number 1 for the first case. And second case, here let me change the color. For the second case, I can write also that a is equal to, rate of change in velocity. So a is given to minus 0.4, and v minus u by t is 10. So minus 4 is equal to v minus u. This is equation number 2. Now we have to solve these two simultaneously to get the final. She reached the turning point, this velocity. We no need to find u, because it has not been asked. Only when it reached the turning point, here I need to find this. So solving this, I can take u is equal to v plus 4 from here, and substituting in 1, 20 is equal to v plus 4 plus v, 2v becomes 16, v equal to, that goes to be 8 meter per second. This is the velocity when she will come to the turning point. I hope it is clear. Okay, here's another question. A car is traveling at a speed of is given to be 20 meters per second. It means it is starting with u, that's 20 meter per second. When driver sees the traffic lights ahead changes to red, she decelerates at a constant rate of, it means acceleration is negative 4 because it's deceleration, so it will be negative, and comes to a stop at the lights. Okay, how far away the light or driver or this, and when it's come to rest, stops mean v becomes 0 meter per second. So it's 2as is simple case, that's v square minus u square. We can apply the third equation of Newton motion. So 2 minus 4 times s will be 0 square minus 20 square is minus 8 is equal to minus 400. It has, so s will be 400 divided by 8, minus minus will be cancelled, yeah. So 8 5 is 40, so it comes to be 50 meter. That's the answer of this question. It's a simple question. And similarly, we can proceed to next. An aeroplane accelerates from rest. It means u is 0 along runway at a constant rate of this one. So acceleration is constant 4 meter per second square. It needs to reach a velocity of this one, v should be 80 to take off. How far long the runway needs to be? So we are looking for this. Is again case study as third equation of motion, v square minus u square. You can apply it. 2a is 4, s we are looking for, v is what, 80 square minus u 0 square, 8s is equal to 6400, s will be 800 meter. I hope it is clear. Okay guys, here the question, another question. A driver sees the traffic lights changes to red 240 meter away from when he is traveling at a velocity of this one. It means s is what, 240 meter, and velocity is what, 30 meter per second. Yeah, that is u, the initial is traveling with. To avoid wasting fuel, she doesn't brake, okay, but lets the car slow down naturally. The traffic lights changes to green after 12 seconds. T was 12 seconds, it's given us. At the same time as the driver arrives at the lights, okay, it means she just neutralized the car without accelerating it. And find the speed with which the driver passed the lights. So we are looking for this. Is a simple case study. S is equal to what, we can apply here, yes, better one. S is equal to half u plus v times t, or second or third equation, second equation of motion, the same case. It's given 240 is equal to 1 by 2, u is 30, we are looking for, and time is 12. So 12 12s are 12 to 24. We get, simplify it, we get 60 is equal to what, 2 6 6 4, sorry, 40 is equal to 30 plus v, so v will be 10 meter per second. This is the answer for the A part. I hope it is clear. Now what assumption have been made to answer the question? Now you have to write any assumption, because when it reaches the light without wasting fuel, it means you can say that he is traveling with constant deceleration, traveling with constant deceleration, because slows down. So this is the assumption. If you have any others, you can write after going through the notes.